Okay, thank you very much for joining me again. This time I'm going to be talking about applying boundary conditions. So basically I'm going to start with doing boundary conditions on a beam element because it kind of depends on what you're doing here. And then I'll move on to boundary conditions on a solid element. They're a little bit similar, but they've got some different tricks to them. So first, let's see, if we go into our so I've got this beam element here. Sorry, let me explain my model a bit. It's a beam element with the square cross section and circular. This is a 1x1 rectangle, and this is a 1/2 inch radius circular cross section. So you can see that they meet up, on the tangents here. Anyway, not the best mesh, but that's what we're going to work with. So applying boundary conditions is basically saying where do I want my model to not move, and how do I want to constrain it, or maybe I can say, hey, hold this part, hold the the left side of the wall, and push the right side up by 2 inches, and then tell me what the forces are, from bending it. So let's see, I can go into that's under loads, define loads, so kind of a big menu here. Loads, define, and apply. Structural, and then this is all going to be under the displacement menu. So loads, define, apply, structural displacement. And we can say what we want to put our displacement on. So if I want to say, don't make this, make this whole line not move, great, I can do that. But this is a beam element, so I've got key points and I've got lines. I'm going to say on key points. So I'm going to select this guy on the left side, this key point at the origin. I'm going to hit OK, and this menu pops up and it says, do you want this thing to not move in the X, Y, or Z direction? Do you not want it to rotate in the X, Y, or Z direction? So if I wanted it to make attached to a wall, I would just say all degrees of freedom. But let's say I wanted it to be a roller joint, and I want it to be able to roll up and down in Y. So that means I'll select X and Z so that it can only roll in the Y direction. Whatever you want it to whatever direction you not want it to move in, that's what you select. And I'll hit OK here. So, and then I want to say I put a force on the end. I need to apply a force or moment. I can, again, here I'm going to say at key points. I'm going to select this key point here at the end. I'm going to hit OK. And then at what direction do you want this? Or do you want it to be a moment in a certain, along a certain axis? So I'm going to say, keep it simple here. I'm going to do it in the Y direction. And I'm going to say -1,000 to, pull down with 1,000 units of force, whatever you're in. So if you're working in metric, that's newtons. If you're working in US units, that's pounds. So I say OK, and I've here got this red arrow pointing down in the Y direction to represent my force. But if I wanted a component force, say a certain amount of force coming off at an angle from the end of that beam, I'd have to add a second direction, basically another component. So I would say key points. I'd select this guy at the end. I would hit OK, and then I would say, sorry about that, I would say in the X direction, and positive 1,000, hit OK, and there's my other arrow. So now those can add up, 1,000 in X, 1,000 in Y. That adds up to a vector or a force vector at the 45-degree angle. But if I wanted to put a force in the middle of this beam, I could say force on nodes, and then I could select any one of these nodes along those lines that I drew. So remember, in a beam element, nodes are along the lines that you draw, not everywhere around your shape. That actually is modeled. So those original lines that I draw, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places I can choose along the cylinder, and the same amount along the rectangular prism part. So if I want to put it in the middle, I select this node right in the middle, hit OK, apply my forces. You get the idea. This warning is important here because I'm going to talk about doing distributed loads. So this says that as solid loads are transferred to the nodes or elements, they can overwrite directly applied loads. So basically, got to be careful because sometimes if you apply distributed load, basically that's applying a small amount of load on every node, and that sums up to a whole distributed load. Sometimes if you do that and then apply point force, the point force will delete the distributed portion at that node. So the point force will delete the portion of the distributed load that is at that node. Sorry, load and node sound the same, so let me Try to stay a little clear here. So I'm going to clear those forces in the GUI here using delete structural force on key points. I'm going to select these key points here, hit OK, all forces to delete, and there go the forces there. So, oh, lost my model. Let me double check I've got this guy gone. Alright, just not updating the photo. So, I'm going to go and add or apply structural loads, a force on nodes, but I'm going to do a distributed load. So I want to do a, let's say 1,000 pounds over the whole, distributed over the whole beam. So we're basically going to use this little box option right here in this menu. Left click and drag a box around this whole thing. I've got all those nodes selected now. So notice the count is 41. So I've got 41 nodes here to work with. And OK. And now I want 1,000 pounds, downward, but I want it distributed over all 41 of those nodes. So I'll put in divided by 41. And there I have it. There's my distributed load. 1,000 pounds over 41. So technically, there's 24.39 pounds, on each node. That sums to 1,000. It's distributed over the whole beam. So that's a distributed load on a beam. And so the next thing you have to do is talk about putting displacements or constraints on a solid model. So give me a second here. I'm going to clear this code and bring up a solid model. I'm just going to make a simple volume. So let's see, clear and start new. Alright, quick element types here. I'm just going to use solid 185. And then I'm going to go ahead and model a volume. I'm just going to do a block just to make it simple here. Start at the origin. Let's do 5 wide, 10 high, and a depth of 2. Just keep it simple so we can keep our axes straight. So there we have it. There's my volume. So let's say I wanted to constrain this volume along a wall and pull on this right side here. How would I do that? So I'm going to go straight down. I'm going to skip meshing. Hopefully it'll let me do this. I'm going to go and define a displacement. But think about it. I don't have any lines here. I do have areas. So I can put a 0 displacement on this left face here. Remember, I'm left clicking and dragging. And I let go, select that area, hit OK. And on that area, I want all degrees of freedom to be restrained. So I've got that little symbol there. This left face is now constrained to the wall. So if I want to go to the other side and pull on it, let's see what our options are. Apply a force. That's not very helpful. I've got key points and nodes. So maybe there's another way to do this. I go up into pressure. Oh look, I can apply pressure on an area. So what I'm going to do is actually apply a negative pressure along this whole area, and that's going to simulate pulling on that face. So if I select pressure on areas, I can select this area here and hit OK, and then it's going to ask me for a pressure value. So by default in ANSYS, pressure is onto a surface. So if I was to type in 1,000 pounds, that would be 1,000 psi applied onto this surface right here. So you've got to do the math yourself to find out what the total force is. But if I wanted, let's say, keep it simple, 10 psi and negative, that's going to pull away from this area that I selected with 10 psi or 10 newtons per meter squared, whatever unit system that you're currently using. So I hit OK, and then I've got this interesting symbol right here that says that there's a pressure on that area. So then I can go ahead and solve that, and that would show me what it would, that would simulate this block being attached to a wall, and I'm pulling on this right side over here. So there's another few options though for applying forces to solid models. So if I had a mesh going here, I could go to apply structural force moment. I could apply a force on nodes, because when you create a mesh on a solid model, each intersection of those white lines that goes all over the model is a node. So it's going to tell me there's none defined, but imagine I have that white grid everywhere. I can go in and apply forces on particular nodes. So the same thing applies for a distributed load. I could do a side view here, I could do select nodes and use that box command and select just the nodes, on the tip of this. I could box just the tip, and then I have all the nodes along this line selected, and I can simulate, a point force on the edge of this volume. You can do it that way. So basically there's the two tools you have: applying forces on nodes after you've meshed, and applying a pressure on an area. There's a few other ways, but they don't really apply much to this class. They're kind of out of the scope. But that's the basics of displacements and forces in ANSYS. So thank you much again for watching.